so my name is Nadine Carew. I'm project manager at Turner Construction, been around with the company for 12 years now. I went to Cal Poly, graduated construction management, and I went to the University of Bath in the United Kingdom to do my MBA in strategy and risk management. Roles I've had with Turner, I started as a field engineer, became an assistant engineer, project engineer, and now a project manager. So that's kind of my path throughout Turner. These are some key focus projects I wanted to show. I'm going to hit on 3 of them today, but I still wanted to kind of show the diversity Turner kind of deals with projects. Levi Stadium, we're going to get into a little more. VMware Tech Campus, not going to talk too much about, but that was a great project in Silicon Valley that we finished a few years back. The COVID Field Hospital, very near and dear to my heart, we'll look at today. And then my current project, which is a launch pad in Florida. Real quick, I don't want to bore you guys with this, but I kind of want you guys to also see the bigger picture of Turner operations team, which is more focused the project teams and what they consist of. You know, we have the safety managers, very key part of any Turner project. We have our superintendents and engineering, we'll get into a little bit. We have the cost and finance team that really helps us stay balanced. Our operations manager kind of looks at the entire business unit and makes sure every project has the proper people and resources and things are flowing correctly. Project managers, we really focus on making sure the team is in a good position, the project's in a good position. VDC manager, Matthew, will talk a little bit more about, but they really help us focus on staying ahead and staying proactive and seeing things that real quick, don't want to get too into the details, but I wanted you guys to kind of see big picture here, the roles, the major roles on a Turner project. So the project execs, their real focus is to make sure our team has the resources they need, whether it's people, whether it's hard conversations we have to have with the clients or our trade partners, but that's really their focus, to make sure things are gelling. The project manager, our role is really to define very specifically what everyone's role is on the job. What is the expectation of each team member on the job? You kind of see on the bottom of the slide, it says a successful project starts when each team member understands their role and responsibility. That is critical part of a successful team. So my job as a project manager is to make sure expectations are set, people know what they own and what they're supposed to be doing on a day-to-day job. Project superintendent, they focus more on creating the schedule with us. They create the logistics plan, they make something buildable, right? Project engineers, they focus more on the process and procedures of the project. What does the RFI flow chart look like? What does the submittal flow chart look like? How much time do you have to review this? How much time does a trade partner have to review it? That keeps things gelling and moving. Project engineer also kind of manages the engineering team, right? We make sure we're on track with costs. We make sure we're on track with the communication with the client. Project engineer is the heart of a project a lot of times. VDC manager, again, VDC manager really supports the project to make sure that we're seeing things that we will not typically see. We're planning ahead, we're looking ahead. Our trade partners are giving us what are owed, and things are getting worked out before the field. That's the intent, right? And then the safety manager, very important position at Turner. We're safety first at Turner. Make sure that the trade partners are building safely. We're not just building fast, but we're also thinking of safety first. So that's really the safety manager's role. So real quick, okay, Levi Stadium, I started this job after 3 years being with Turner, and it is still by far my most favorite and monumental project at Turner, right here in Santa Clara. We built this $1.3 billion stadium in only 25 months, which was extremely impressive. And it was only due to the fact that we were able to implement lean practices, which we'll talk about here. 75,000 seat capacity. It was the first at the time and only NFL stadium that reached a gold certification. So we were really proud of that. Lean construction. We were completely 100% focused and invested in what lean construction meant when we built Levi Stadium, and we'll get into a little bit what that means and what that looks like. But the idea, big picture, is we focused heavily on our relationships and the people and the expertise of our trade partners. You know, a lot of times on traditional construction jobs, a GC or a general contractor is creating a schedule with little input from our trade partners, right? The architect is drawing things up with little input from our trade partners, and we're kind of saying, here, go build it. And what happens with that mindset is it's a very hierarchy based, and it's very little buy-in from the people that are actually going to be doing the work, right? So this is a traditional project, right? But what I really want to show you guys is how Turner built it and how we try to build all our projects, right? So very lean, collaborative focus. Another thing you could see here is the verbiage. We do not call them our subcontractors. We call them our trade partners. And that in itself gives you a different dynamic of a relationship. They are our partners, right? The concrete sub is not a subcontractor to Turner. They're our trade partners, right? They're the experts. They're the ones that tell us you could build this better and faster if we do it this way, right? So we had heavy coordination meetings. We probably sat in 3-4 hour meetings a week before we started even construction. And it was brutal, right? We sat in meeting rooms and we were like, holy crap, when are we going to get in construction? But we knew that if we got this right and we all sat in a room and designed the thing together and bought into it together and signed it off together, once we got that out of the way, we were going to be golden. And that's what ended up happening. So at Turner, we call lean scheduling or pull planning, right? And what this means is every trade partner sits in a room with Turner and the client and the architect at Levi's. And we sit there and we say, how are we going to build this thing? Every trade partner has a designated color Post-it, and they start putting up there. They go up there and say, hey, I could do this in 1 week if I get 5 guys and no one's in my way. Or, okay, if you want this person in my way, I'm going to need 10 days. And we sat there and we started, you know, putting all our thoughts on the wall, how we're going to sequence the work. And we let it kind of all shake out with everyone in the room together. And then that became our project schedule. Okay. Turner didn't create it in a vacuum by themselves. We had complete input from our trade partners. And that was a big part of the trade partner believing in the schedule, buying into the schedule, and then owning the schedule, because they gave us the durations, right? They gave us what they needed to be successful. The BIM coordination, Matthew's going to talk way more about it today. He's the expert. I am in no way an expert on BIM, but I was a recipient of the benefits of what BIM did for the job. Okay, so I just want to show you guys big picture what it did. You could see we completely BIMmed the entire project inside and out. So the design team gave us a very typical 2D drawing. And then we said, okay, we understand what you want, but now we're going to decide how we're going to do it and what's the best way to do it. And that's what you kind of see the evolution of the BIM drawing. And you could see here, we had 260,000 linear foot of underground conduit that we ran prior to any of our piles being driven, which is very uncommon. Usually you drill the piles and you kind of try to spaghetti your way around it, but we did all underground conduit, all underground piping before any auger piles were drilled. And this allowed us to work 24 hours a day. We didn't hit one piece of conduit because of how heavily we coordinated and how much we invested ahead of time prior to do any real construction in the field, right? So you could kind of get an idea here how much our BIM model, what looked like the end of the day result, right? So you could see the top left down here, that's kind of just a cover for our escalator, a protective cover, but that's an escalator on the bottom. And then you could see on the right, the full stadium. So this BIM model, I was not even very, you know, a believer in it until Levi's, when I was like, oh my God, like this completely saved us. And the math came out to, we found over 5,300 clashes at Levi's. And we estimate about an hour and a half of lost time should that clash have happened in the field instead of in the model. And so had we not used the BIM model, we were about 334 days of lost time, right? That project would have finished a year later than it did had we not invested in the coordination and the lean practices, including the BIM model. So this right here is just like a tangible result that you could measure to, that you could say, holy crap, that coordination really bought us and saved us this much time, you know? So when you do the math, you kind of can't argue the fact that this really was one of the strongest factors of our success.
Did Matthew plant this information for you? So you
no, Matthew,
I don't even feel like I need to present now.
I didn't
This is
even
great.
show Matthew this, but I'm hoping he's, he likes it. Another
Sure.
big part of Levi's was the prefabrication. So once we got the BIM all signed off, the BIM model, the BIM model comes with the mark numbers. Those mark numbers were put into the plasma cutters in the shop. And then you get all these runs of prefabricated piping, right? So on the right side, that's a restroom. We wheeled in entire restrooms, entire concession stands, right? We were able to do that because of all our heavy coordination. So imagine trying to put these pipes together one piece at a time in the field. It's crazy, right? And the measuring and remeasuring and the cutting and the wasted time and the wasted efforts, RFIs, all that stuff that comes with it, had we not prefabricated. And instead you get quality work in a controlled space like in a shop. And then we got all these pieces that we came out and mass produced and mass delivered. Field install rolls right off the back of that, right? So you could see we have a term at Turner, everything on wheels. So unless it's on wheels or on a pallet, it's not going to touch the ground, because what that does is when you have heavy pieces of equipment or ductwork, you're causing more chance of injuries, right? People, back pains, back sprains, lacerations. The more times you touch a piece of equipment, the more likely you'll damage it, right? You see how organized it is on the right side. When a trade partner needed a tool, they knew exactly where to go, exactly where to get it. They're not wasting time looking for things. You see the tripping hazard on the top right, we put our cords up instead of on the ground. So all of this is considered lean construction, right? You do things efficiently, you do things safely, and you provide quality at the same time. That is lean culture. Right. And that's what we so heavily talk about. This is just a cool feature because it was my favorite feature at Levi's. So I had to show you the green roof on top. It's on the top of the tower. That's a big part of how we received gold accreditation or certification. It has all these really cool types of vegetation. We actually give it to local restaurants on their menus. And it's awesome. It's beautiful. It's physically beautiful to look at. And we have over 1,100 solar panels on the roof.
Wow.
So this was the team here. Top left, it was a Turner DevCon joint venture. Great team that gelled really well together. The right side was kind of a cool picture for me because I remember feeling that feeling of sitting in that same spot, watching construction happening, and then that same spot are the seats I got for my season passes, because I was just like, I need to, experience this. And we're so lucky in construction that we have something tangible that we could look at the end of the day, that we could walk, that we could experience. I'm a huge 49er fan, so it hit on a different level for me. But not every industry has that pleasure, right, of seeing your hard work come to life, the team's hard work come to life. Is that a hand raised or like a high five? I don't know tech that well.
It is clapping.
Thumbs up.
Great speech.
Thank you. I'm still new at this little,
Like this. Woo, woo.
Oh yeah, you're right there. Okay. No, but this was a monumental moment, and I just wanted to share it with you guys. Okay, next one. This is the alternate care facility. So back in April of last year, a state of California and the Department of General Services came to Turner and said, hey, we need help in Sacramento. We need to support our local hospitals. They're getting drowned by COVID patients, and it's really interrupting the regular flow of hospitals that needed, other care, other treatments that needed. Cancer patients were suffering. And so what we did was, what they asked us is, the Sleep Train Arena was where the Sacramento Kings used to play. It was abandoned at this time for 3 or 4 years. And they said, can you make this a hospital? And can you make it a hospital in 2 weeks? So we're like, oh, okay, we can, and we did. And we created a 328 bed hospital in the abandoned Sleep Train Arena. And I wanted to just give you guys an idea, big picture. We had 40, 80 ton temp HVAC units to kind of get the air pressure where it needed to go. You could imagine an abandoned stadium. There was nothing about it that was hospital grade at the time we walked in, right? We had emergency generators. Everything had to be 24-hour generators. We had to build temporary showers for the patients, both male and female, obviously. New fire sprinkler system, new flooring, because it all had to be washable and hospital grade flooring. and a bunch of little things we had to add everywhere. So pictures, this is the arena floor where usually the court would be, right? The basketball court. And you could imagine how cold it was when we walked in there. And a hospital has to stay between 68 degrees and 74 degrees Fahrenheit. So it took a lot for us to maintain or to even achieve that temperature. So we threw hundreds and thousands of cables from the catwalk above, and we started putting this flex duct in and tried to maneuver in a way that achieved that temperature, right? So you could see these are the negative air machines. So, you know, we have sick patients in the facility. We don't want the bad air to keep circulating, making people more sick. So we had to put all these negative air machines that kind of sucked out that bad air from the facilities. These are the temp showers we built for them. This is the new flooring we had to do for it to be hospital grade, washable, completely sealed. This was the coolest part for me. You know, Turner, we build buildings, but we first think about who's going to be using the building, right? And these were going to be patients, or they were going to be healthcare workers that are going to be stressed at the very best, you know? And we thought, like, let's make people feel as good as we can while they're using this facility. So we reached out to the community and we reached out to other people and said, create art that's uplifting, and we'll hang it around the arena and we'll hang it around the stadium, right? So you could see up left is from Turner people from different school districts. And what that did, and you see the patient room on the bottom right, that when people would utilize the facility, we were trying to make it as best we can considering the circumstances, you know? And this was really important to us because we don't just build things and walk away. We think about, you know, what we're building and who we're building it for, right? This was the finished product in the arena. So you had beds on the arena level, you had beds on the suite level, on the concourse level, and in the practice facility. But this here is the arena itself. And this was the team.
A quick question, you might be, did they actually put any patients in it?
The practice facility, which I didn't have a picture of, did. The arena, the good news is we just took it down like 3 weeks ago. Originally, it was supposed to be a 90-day project only because they thought COVID would be gone in 90 days, right? But we left it up until about 3 weeks ago. So almost a year now, it's been up, but thank God the arena didn't need patients. The hospitals were able to maintain the patients, but the practice facility is still in use and still operational right now. You know, they're waiting for this next surge to kind of die down before we dismantle the one next door.
Thanks.
But yeah, this is the team that made it happen. You know, 16 days of no sleep and no showers. So we all got really close. But it was really cool. Okay, last one. This is the current project. Now, this picture is of the New Shepard. We're building the New Glen. This is in Texas. We're in Florida, which is about 3 times as large as this one. But I just want to show you this one because it's a cool picture. But so Blue Origin, privately funded launch facility owned by Jeff Bezos, who we know also is or was the CEO of Amazon. Quick intro about it. So what Blue Origin and SpaceX and all these guys are trying to do is they want to become a commercial air flight, but into space, right? So instead of United and Delta flying across the world, they want to fly in space. Okay. So right now what Blue Origin is focusing on is sending up payloads. So just New Shepard last week sent up payloads, and payloads is just a fancy word for satellite. And what these satellites are doing up there is creating like an air traffic control for space. So when people want to start traveling in space, which is sooner than we think, in about 8 to 10 years, they're thinking that the moon will have communities for people to go work on. These payloads are creating air traffic control to find the smoothest flight from Earth to the moon, right? The area with least radiation, volatility. That's what these payloads are doing right now. And by next year, the New Glen and Blue Origin is going to be offering up humans to go up there for whoever wants to do that. Not me, but some people are into that.
Or can afford to do it, right?
Yeah. Oh, I don't even know what that costs. So yeah, we're hoping to be done in a few months. And unfortunately, the project is ITAR, International Traffic and Arms Regulation, which is a fancy way of saying super confidential. And I can't really show you any cool things, but I'm going to show you big picture kind of what we're building out here. I can't show you the systems. I can't show you the things that really, I would love to show you the BIM model. Matthew, you'd be so impressed with us, but I can't really show it. I'm not allowed to. But just for reference, you see the Statue of Liberty on that right side, and that's the New Glen next to it, to give you some perspective of size. It's huge, right? We talked a little bit about the payloads already. And what else do I want to show you before I show you the video? I'm really going to just talk through a video. These are the new liquid nitrogen engines. There's going to be what, 7 of them, I think, or something, and they're the first of its kind. It's all renewable gas and all this craziness that Blue Origin is kind of leading the way on. This is our project site. Before I show you the video, to give you some bearings and perspective, this right here is where the number 7 is the IF facility. This is where the rocket gets prepped, right? It gets ready to get sent up this ramp. So it comes in here, it's horizontal at this point. The engineers prep it, they walk it up this ramp here, and then we have pistons below here that kind of turn it and make it vertical. Now, a big part of Florida is the weather. They have hurricanes, they have a thunder and lightning that's very dangerous during a flight. So these up here are fiberglass pistons above, and they kind of catch all that. There's a catenary system up there that kind of catch any lightning. Everything is grounded on the job. This is our liquid nitrogen. This is our liquid oxygen. This is our liquid hydrogen, all below 400 degrees Fahrenheit. So you can imagine very dangerous fluids. We're very, very high on safety here because failure would be catastrophic, right? Before I get to the video, anything else cool? This is really cool. We have the tallest water tower in the world. It releases 1 million gallons of water during launch, and what that water does is really absorb. It's an acoustical pressure that absorbs all that you could imagine, like when the space shuttle goes and those engines turn on. Without that water to absorb that acoustic energy, it would be a catastrophic explosion. So it works almost as a cushion as well, right? And it works for the smoke and the fire, but its real purpose is to absorb that acoustic energy.
Nadine, do people have to not be around when that happens? Like, is everybody like?
We're around. We're around. I mean, we're not very close to it, but we're close enough where, you know, things have to work for us to be safe.
Yeah, interesting.
But we are close to it. And so I'm going to just talk through this video real quick, but it's kind of cool. It kind of shows you as much as I can with ITAR. This is inside that facility where they're going to be prepping that rocket. It's enormous, and you can't even tell to scale how large this place is. And let me just forward it through. You guys could see it, right?
Yeah.
Okay. So forward. This is the route it takes. You see it goes up that ramp. Another piece that I didn't mention is how close we are to the ocean. So you can imagine the corrosion. You could imagine how much we have to prep to make sure that this doesn't rust, right? So these are the catenary systems we talked about. Kind of hard to see. I think the camera will go up so you could see it. And this is where the rocket will take off. So again, logistically, you could see how close we are to the ocean. A big part of our construction and our strategy. Here's a fiberglass pistons that kind of catch the lightning and travel it down to the ground instead of to the vehicle. Vehicle is just another way of saying the actual rocket. Here's the tank farms we talked about, the liquid oxygen, liquid nitrogen. And yeah, here it might be hard to see, but these are where the pistons will turn it vertical from horizontal. This is in here, we call it the hydraulic pit. The heart of the job is underneath this slab here. Again, hard to see, but as much as I can show. So there's that. Where did I go now? Okay, so that kind of gives you a good idea of the job. Again, here's the towers. Here's a catenary system we talked about that catches all the lightning. Here's how the engines work. You know, I don't want to get too much into science, but really cold fluids that we're working with. In order for something to fly, you need a fuel and you need an oxidizer, right? So that's liquid oxygen as our oxidizer, and our fuel is either the liquid nitrogen or liquid natural gas or liquid hydrogen. Those are the two fuels that we're using for our rocket. And here's a picture of that kind of what it's going to look like. This is what the payloads look like that are going into space right now. One just went in last week. Unique safety measures, not going to get too far into this, but Sherry loves this. Things we have to deal with out here in Florida on the job site. This is on the job itself. You know, we have alligators as guests that come and pop up when they feel like it. We have this guy here called the brown recluse, which is poisonous and your skin literally melts off your body. That's fun. A snake. This was actually what I had to do to the snake because it crept up on me, this cottonmouth snake. And then the hurricane, just to add to it, you know, another piece of the puzzle that you have to manage. And this is just awesome. This is part of the team members. I just want to show it because it's just a cool picture of some of the team out here at Blue Origin. Awesome team, awesome group of women as well, which Turner is big on. So I just wanted to highlight that because they're doing an awesome job. The whole team is, honestly, but it was just Women's Week the other day, so thought I would share that. Last slide, or second to last slide. These are just the systems that Turner relies heavy on if anyone's interested in knowing a little more on what we use, right? So P6, heavy on scheduling, it helps us. Autodesk in general is a big one for us, one being Navisworks. Procore, big on our drawings and coordination. SAP for financing and cost. Bluebeam and Bluebeam Studio, big on coordination and drawings. Power BI, you know, a little more fancy just to make something look a little more presentable, usually to clients or that sort. So this was just kind of a quick screenshot of programs or softwares I depend on through my day-to-day at Turner. And that's pretty much it. Teamwork, integrity, and commitment. That's kind of what we talk about at Turner, and we kind of want to show you it's not always pretty. You got to get your hands dirty. You got to get ready to kind of jump. And that's what we do at Turner. And this team here did the Sacramento Kings new arena. Why the sleep train is abandoned today is because we built this new awesome arena too. And this was the team. So it just comes down to the teams that make this possible. So I just wanted to highlight that for everybody. And I think that's it. Did I make time well?
That's a lot of content, by the way. And you set up Matthew nicely with all those apps, fancy apps.
Yeah, you really did.
Good. Now, Matthew, you have to steal the screen from me because I don't even know how to unshare. So
I think you could just
No, it says I can't.
hit the
start.
green.
I did. But that's all I got. But I hope I stayed on time. And
That was excellent, Nadine. Thank you for sharing. And also, like, you are a big advocate for BIM. I didn't know. It was a secret.
I keep it to
Excellent. So my name is Matthew Warren. I'm the project manager here at the VDC department in the Bay Area. I worked for Turner for 3 years. And a lot of what I do is kind of Nadine touched on, but just give you some background on myself. I practiced architecture for 9 years. I went to Berkeley, got a bachelor's in architecture, and I was doing that career for over 9 years when I decided I wanted to do something different. And I actually went to work for Turner, not because I wanted to be a VDC person, but because I wanted to work for Turner, the company. So actually Sherry is the one who helped me get hired. She pointed me in the right direction, got me connected with the right people. I talked to, basically had to understand what Turner was. I heard they were good to their employees, but I had no idea what I would be doing there. So they brought me in on VDC, and I've since become the VDC project manager for the Bay Area, which has been really fun. And my background, I've worked in architecture and construction. I've done residential, healthcare, commercial TI, education, pretty much the gamut. So I'm gonna go over, we offer a lot of different BIM services or VDC services here in Turner. And I'm gonna just brush on all of these just to give you an overview. And then I'll give you a couple project examples where we actually use some of these softwares and some of these techniques that I think you guys would be pretty interested in. So first off, I'll just spend a minute to define BIM. So BIM stands for Building Information Modeling. Basically, it's turning your generic 3D box into an object and telling the computer what that object is. This object is now a table or a chair. Using the information, or inputting that information into the model makes them smart. And then we can say, show me all the chairs. How many doors do I have in the project? How many square foot of cubic yards of concrete do I need? All of that stuff can come from these intelligent models. And so when we use the term BIM, that's what we're referring to, is basically a smart model with information integrated into it. So we use BIM for literally any phase of the project. The more the merrier, really, because again, we're planning ahead of time. As Nadine pointed out on the Levi Stadium, the more we can plan, the better we can build, the faster we can build, the smarter we can build. Just some quick highlights. Turner is the #1 BIM contractor for 8 years straight. We've had 61% more BIM volume than our nearest competitor, with 9.9 billion in BIM revenue in 2018, with over 1,300 BIM and VDC staff members, which is, and that's just constantly growing. It's becoming more and more the way to the future.
What do you think that number is for 2020, Matthew, as we continue to have more and more BIM?
Yeah, I need to get that number. I need to find out who got this, so I'll find out, but I'm sure it's more for sure.
Yeah, I would think so. That's interesting.
So project launch, as I said, we work with the project from the beginning to the end with various different softwares and techniques. So we get involved in estimating, we get involved in model creation, we get involved in procurement. Really, we have our hands in everything. And one of the examples in the beginning of the project, we need to plan how we're going to construct it. So we do a lot of logistics planning, and we build logistics models. So we're virtually building the building ahead of actual construction. Here's a couple examples of we wanted to plan for building this building. So on the left here, we have demolition. So we're demolishing an existing building. We're using areas adjacent to the site for laydown, and we're showing the truck routes, how the workflow is going to operate in the building. And then we can show steel construction. We can show foundations being poured. We can show the sequence of that construction activity. And this is a powerful communication tool. We use it all the time. Virtual trade coordination. This is probably what we do the most of, or that makes up the bulk of our work. Basically finding out where all the different trade subcontractors or trade partners are going to be occupying at any one time. So where is the mechanical system? Where is the plumbing system? Where is the electrical system? We use the models from the trades to give locations of all of these complicated systems, and we plan for them in 3D. So we can easily identify how to solve an issue before we're out in the field with the pipe cut, with the ducts installed. We can figure that stuff out ahead of time. It makes things a lot easier. As Nadine pointed out, we can just show up with prefabricated duct runs or plumbing systems and just drop them off and install them, rather than having to spend time in the field when time is of the essence. It also helps for things like this, where it's a complicated geometry. We can coordinate this system using computers rather than having to pull out tape measures and protractors and whatever else you might try to use to figure this stuff out. So planning that stuff virtually is a lot easier.
So we have a question in the chat.
Yeah.
Someone asked, what did you use before BIM? Can you explain a little bit of that?
Yes, it's funny. This slide, I deleted the old image, but it actually, they used to use light tables. So they would draw plans and have all their systems laid out over each other. And then they would have to just try to see where they conflicted top to bottom, but you didn't have a good way of understanding how those systems interacted in 3D space. Great question. So.
That's a good point. If you guys do have any questions along the way, feel free to chat or raise your hand or be vocal, whatever. Just don't hold back.
Yeah, absolutely. At the end of this, I'll find that photo. It's really funny because not only are they using an antique light table with old blueprints, but the guy has a really rocking ponytail. Really shows you the times. Okay, 3D modeling. So again, all of this stuff is done digitally, so we can also build 3D models ourselves. So we use those for pursuits, for trying to get new projects. We can use them for coordination. I'll show you some examples of how we've built models in the past to use on our projects. This is a good example of how we built this model. We were planning on putting this tank into this factory through this skylight, and we were able to model that and then create an animation to show that installation sequence to make sure that it fit. And everything looks good until they prop this thing up into this little steel opening. And you'll notice everybody's like, good, this is gonna work, up until right about now when it actually hits the steel and doesn't fit. So you can imagine everybody would be in here. We would have already spent more than a day trying to get this logistics plan, trying to get the crane in here, get the hoist, figure out how we're gonna prop this thing up. And we would have been at that step and realized we had to backtrack and figure out another way. So we built this digitally, and then we figured it out in less time and less cost to the project.
Another question from the chat. How
Yeah.
much do you get from the trade partners when designing the beam?
How much do we get from the trade partners?
Hey, Matthew, that was my question.
Yeah.
It's my question more so is about working with the mechanical, electrical, and plumbing. Are you working with trade partners like as the subcontractors, and they're going through these plans with you the whole time?
Yeah.
You need drawings yourself and kind of trying to see or foresee the future possible issues.
Yeah, no, that's a great question. So the trades will actually provide these models. So the mechanical guy draws the mechanical system, plumber does his, fire protection does his, and then Turner just puts all the models together. And then we find out where there's issues. So the trade contractors are all working with us to make sure, and they're doing their own modeling. But we can subsidize and add additional modeling as needed. It's a great question.
Hey, I have another question. Thank you, Daniel, for asking that. That also inspired me to ask another one. So, what kind of file or the plan you get to design those from all the subcontractors? Like
what what do we get?
Do you get like a Bluebeam? Do you use like a Bluebeam
files.
file to understand their plans?
Yeah, so we actually get 3D models. So we'll get Revit files, we'll get Navisworks files, we'll get AutoCAD files. We determine that back in the project launch. We'll figure out what software we're going to use on this project, make sure everybody's aligned, and then we start collaborating and getting those 3D files. But it depends on the project. But sometimes it calls for 2D Bluebeam sessions. Sometimes it calls for 3D Revit models. Great question.
Okay, so you're the organizer of all sorts of information.
Exactly. I'll show more of that at the end here. Let's see. Laser scanning has become more and more popular lately. We can't stop using the laser scanner these days. We can go out to a job site and record existing conditions down to fractions of an inch with extreme accuracy. And we collect millions and millions of data points that we can then go back and put into our models and understand what exists in real space. And we can put that into our models and coordinate around it. Here's an example where we scanned this complicated lab project where we scanned all these pipes that are in gray are existing, and then all the stuff in blue is the new systems. So you can tell that we needed to coordinate all these exact locations, and trying to come out here with a measuring tape just wouldn't be very feasible. Same thing over here. This is some pool piping on a recent project that we're working on down in Soma in San Francisco. I'll show you this model and how we actually collected a point cloud of the existing conditions and then coordinated around it. We use the models to influence our schedule. So in the same way that we can show construction sequence for logistics plans, We can go as granular as we'd like, and we can show the actual sequencing of glazing or concrete floors, steel construction. And then here is the example I'll show where we did a 4D schedule of the LA Rams Stadium. So this is down in LA. A huge, I think this stadium is actually more expensive than Nadine's now, unfortunately. But here we can show all the sequencing of the steel, how in which order that we're erecting the columns, where we're starting to pour concrete. This project had the world's second largest crane. And you can imagine that that crane was very large and it takes a long time to move it. And it's also very expensive. So making sure we make use of that crane is critical, and we make smart decisions with it. So planning the schedule ahead of time using the model really helped us to figure out how to optimize crane usage as one example, amongst other things. Okay, cost estimating. Again, because these models have information, they're smart models, we can attribute cost to those same models. And all we have to do is say, this pipe costs $12 a linear foot. The model knows how many linear feet of pipe we have, and boom, we can generate an estimate for how much pipe we're going to need to buy. Same thing with drywall. And this is a lot faster and more accurate than conventional methods of trying to count them where you have human error. Here's an example where we have a complicated geometric roof. What's the surface area? I can just click on the object in the model and it tells me it's 23,500 square feet. So because we're using computers, it's a lot easier to get that information. Operations handover, again, we're putting all this information into the model. We can also put facilities information into the model, maintenance schedules, filter replacements, where objects are located. New building owners are mandating this and requiring us to provide digital files at the end of the project versus handing them a giant binder with all these warranty manuals and product service requests. All that stuff can be stored into the model, and then they can use it to create a maintenance schedule. The maintenance guy just prints out every 6 months, he has to change this filter in this room. He goes to that room to get the filter. It's this filter number, and they need to bring a screwdriver. Like all of that stuff can be stored into the model and generate really quick maintenance recovery systems. Model checking and analysis, we can figure out square footages of buildings, we can figure out ADA clearances. All this stuff can be done very automated and or very quickly through automation, and we figure out problems before they arise in the field. Safety is another big one. We can find out, we can calculate loads on floors. We can make sure that we don't put too much weight on any one place. We can find out where there's fall risks, where there's holes in the ground. We can flag all of that stuff in the model before we're out on the job site where it's more dangerous. Okay, this is a really cool one. So you can imagine when we have complicated geometry, we can model anything we want in in the computer, but how do you then translate that to real life? In this case, we have these curved panels. We have the locations in the model. Now we need to translate that to where that occurs in real space. We use what's called a Trimble or a total station. You might have seen these. We can put data points from the model into the Trimble or the total station, and then that can locate those points in real space by just shooting a laser at it. So it'll tell us exactly where that complicated geometry occurs in real life. Production tracking, we can use Power BI now to figure out where and when objects are been delivered, when they've been installed, when they've been fabricated. We can track the progress of the building construction through the model. And then we have a lot of cool different graphics to show all that sequencing. We're really pushing the boundaries with what we can do with these models these days. Here's another good example of using virtual reality. I'm sure a lot of you guys have experimented with it. We can use virtual reality to create mock-ups of projects. We build the room ahead of time, and then the nurses and the doctors can all experience what that space is going to look like and how it's going to function by putting on goggles, and they can give us feedback. I think in this example, they said, hey, we need that fridge to be on the left side of the bed. So this is the real life and this is the virtual mock-up. So we can learn from these models before we build them. Again, it's always trying to be proactive rather than reactive.
Did you say that was a
last-
refrigerator?
I think it was some kind of medicine cabinet, like refrigerator.
Oh, gotcha.
Yeah, not like where you store soda or anything. That'd be a nice hospital room. Last but not least, 3D printing. This is something that we've been doing a lot more lately, and the sky's the limit on as far as what we can use it for. Just on Wednesday, I was out at a job site. We were pursuing a project, and we printed the massing models for the building and printed out a floor plan. And then we just had the client move the pieces around and tell us where they wanted the different construction sequences to occur. So the client getting their hands on the project made it really interactive and made it much more successful than trying to manipulate that information on a model or trying to get other people to read 2D plans. Having tangible 3D prints has been really beneficial lately. And in this example, we were able to 3D print complicated molding and then put it right in place, paint over it, and nobody was the wiser.
Hey, Matthew,
Here's an example.
Daniel asked the question, do you have like one VDC team for a project or one VDC team like manage several at the
Good
same
question.
time?
That all depends on the project and the assignments. So in the case of like the coordination that Nadine explained through Levi Stadium, that would have multiple VDC engineers on that project. But a smaller project might only have one VDC person part-time, and then that person is managing one or two different projects. So it all depends on what the project needs are. At any one time, the VDC department is working on multiple different projects in multiple different phases, and they all require different levels of services that I've just described. So it just depends, but yeah, it depends on the project. Good question. So this one, we 3D printed a complicated window mullion assembly so that we can understand the installation, the waterproofing, all that stuff before we go out and order all this stuff. We were able to 3D print it, test it, make sure it works, everybody's bought in, and then we can place the order. So I think I've used most of my time, but I just want to quickly show you guys a couple of, this is an example of a 3D model that we've built for a project down in Soma. All the trades provide all these different models. This is just one floor of a 28-story building. Oh, my screen is it not sharing? Sorry, let me share my screen. Now my screen's frozen. There, share. Okay, you guys can see the model now?
It has that you're sharing, so I think it's loading.
Okay.
There you go.
Okay. So here's an example of one floor from a 28-story building. All of these different models are from all the different trades, and they all get put into place. We orient them, and then we coordinate all the different locations of all the trades. So we use this tool all the time. In this example, I'll just show you guys quickly. There's a pool on the 10th floor. And so the pool piping is on the 9th floor and it goes through concrete beams. So we had to coordinate those concrete penetrations. Well, the pool piping contractor didn't provide modeling. So Turner modeled it and then we coordinated the trades around it. And then the pool contractor installed the piping different than when we modeled it. So now we had to go back out and re-coordinate that work. But we had tons of pool piping around all around the project, and it's really complicated geometry. There's no way anybody could just take a measuring tape and figure out where all this stuff is to figure out where they need to put their piping. So we actually went out and took a laser scan of the existing conditions. And if I hide this model, so that's where they were supposed to be. And this is where they ended up installing. You can see the gray areas. So all of this is point cloud data that we took from a scan from underneath. And then we put that point cloud data back into the model, and then we were able to coordinate the plumbing around those locations. And we did all of this in less than 24 hours. So we went out, scanned it, put it into the model, sent it over to the plumber. He was able to revise his work and then give us an accurate, a new coordinated plumbing system.
Question. Hey, Matthew,
Yes.
when you said you asked the subcontractor, I mean the contractor, to re-coordinate it, so what kind of data or what kind of information you give them so they can understand? It probably won't show them the 3D model, right?
No,
How would you
we
let them
worked
know?
all in 3D. So we sent them
Oh, you
this
do?
exact file, and then they got that data, and then they put it into their model and then coordinated. So anytime anything I'm showing you on the screen is the exact same thing that the trade partners are looking at as well.
So they
all
also have
their
a VDC. So they have a VDC person on their team too. That's what you meant, right?
Correct.
Got it.
Yeah.
Perfect. Thank you.
Yeah. Okay, how am I doing on time? Am I wrapped up?
Yep.
Yeah, you have. Yeah, you can do a few more minutes if you like.
Okay, I'll just show you one other project. This is where we did a logistics plan using a 3D model. We built the model and then sequenced the construction, all using SketchUp. And if it loads, you'll be able to see. We can show the concrete installation, the excavation. We have water tanks and water, what were they called? Groundwater drains. And then we can show the structure being installed, all while being avoiding the existing buildings on site. So we can show a flow of this. And then we rendered it. So we took that same information and then rendered it so it looks a lot nicer. And then we presented this to the client with the schedule showing how we're going to sequence the work and when they can expect their building to be built. This is a lot more powerful than just looking at a standard schedule or something. All right, I think that's all I have for presentation.
Looks like there's a question in the chat.
Yeah, one more question
Yeah.
for you.
Oh yeah, so I was asking a question, Matthew. So how new of a technology is VDC and BIM? And do you see this becoming an industry standard?
Absolutely. So BIM and VDC have been around for more than 10, 15 years. But I think more and more it's becoming more of a standard. I haven't worked on a project now that hasn't required some level of BIM. We're even using BIM before we get the project. Like in the example of the logistics plan, that was for a pursuit. We were pursuing that project. We wanted to sell the client that we can do this sort of thing for logistics. So all of that stuff is becoming more and more in demand. Good question.
Hey, just to insert an advertisement, if you're really interested in BIM or VDC, we have the ASC competition next year where you can learn it all in your winter break, then compete and get a job offer for free. Everything for free.
That's great. Sign me up.
All right. You're our captain for next year.
Yeah, you bet.
Right. Our next panelist is Miguel. He graduated from SGSU. Now he's returning to giving back to the community and sharing his experience. Here you go.
Hello. Thank you for having me. I do have a few less years of experience than Nadine and Matthew, so it'll be a little bit shorter of a presentation, but I'm just gonna give you guys some of my insights from what I've learned. So here's my screen, let me share that, okay. Okay, good afternoon, everyone. My name is Miguel Chow. I'm an engineering assistant at Turner. Right now I'm 2 months into my full-time position at Turner, but I've done 4 previous internships. 2 of them being at Turner. One on the top is the PG&E Livermore building that I helped. I was an intern on for my summer of 2018. And then the bottom one is the summer I just did this past summer at Zeiss in Dublin. So those are the 2 projects I've helped on with Turner during my internships. I went to obviously San Jose State Civil Engineering. And as an intern, I was a project engineer intern, and now I'm an engineering assistant. And so what I'm going to talk about today is just a little background about myself, some career fair tips and interview tips, my experience as an intern and a full-time, and then if you guys have any questions, and you guys can type in the chat as well. Okay, so so my background, I attended SJSU from 2016 to 2020. I was an ASCE member all 4 years. I was on the SJSU Concrete Canoe team. You can see our pictures on the right. That's our team from, I believe, 2019, and then right after our race on the bottom. And then I was also part of the SJSU AGC team in 2019 on the commercial team. And then why did I choose civil engineering? I chose it because I always knew I wanted to do something with either design or construction of buildings. And having a dad that is a civil engineer, I became curious to how construction processes worked from a very young age. And it just stuck with me. So the other thing that fascinates me about civil engineering, and what Nadine kind of touched on earlier, is that you are helping create something that is brand new. It's brand new for you, for your family, your friends, and for the public. And they're going to be enjoying it, working in it, living in it. And it's just tangible. So it's really nice to be able to see something that is physically there that you can say you helped to bring to life, you know? So I'm going to go into some interview tips. So for the career fair, I just can't tell you how many times in my 4 years that I just saw some peers and classmates of mine just opt out of not going to the career fairs, especially considering that they're free, they're on campus, and they're civil engineering specific because of ASCE. So always make sure to attend those career fairs, obviously when they can happen again in person. And if you have a few years left in your college career, go to those. And then if you're looking to get a job soon, when researching, I know that when you're researching, there's a standard. Everybody knows that you're supposed to be researching their culture, the company's culture, the industries that they're in, et cetera. But what I found was helpful was to go a little bit deeper and to look at specific projects, specific notable projects like Levi Stadium, like 222 2nd Street, which is a downtown project Turner did in downtown SF. Looking at those specific projects, talking about those specific projects that Northern California Turner has done, I think really it makes you more presentable, that you know what we're doing here in locally, and that it's something that you're very interested in. And then as you're speaking with the company, remember that just like, you know, how you practicing what you're going to say, the posture, the tone of voice that you use, making sure you're smiling, all great keys that will show that you're very interested. And then with something that I did that helped me a lot was keeping track of who I spoke with, and then writing down their names, and then writing down anything from that conversation that was of important value, like when a deadline to apply is, or you know, just writing down this talk with this person went really well. And I actually have a pretty good story about that. My first internship that I did with Turner, I spoke with Nicole Rendon. She was at that time, I think, an engineer, and she was at the career fair. And now, just a couple weeks ago, almost 4 years later, I met Nicole again, and she remembered me from the career fair, and just thinking about how those connections matter from a very early point, at the very first point that you're talking to anybody from a company. That's like the first point of contact, and it could be, you know, helpful down the road. And then also ask questions, like when you're in the interview process and you're going through it, you know, it's a similar approach. You're coming prepared. You're asking questions at the end. You know, when they ask you, do you have any questions for us? Always follow up and ask, you know, what is it like to have an internship experience here? What does an intern do here? And it'll just really show that you're wanting to, you're wanting to fill that position, you're wanting to do well in that position. And then lastly, follow up afterwards, a few days after the interview, just to let them, remind them of your name, remind them that you're very interested in this position that they're offering. So Turner's internship experience, I just can't say enough great things about it. I feel like I have a really unique perspective because I've been able to see Turner pre-pandemic and mid-pandemic to see how they operate and how things may have changed. Thankfully, I can say I had a great time during both internships. Turner really made an effort to make interns feel welcome through happy hour events, through job site tours. That was during normal times. And while also giving us some meaningful work to do and to gain some experience. Another thing I really liked about Turner's program was to just talk and hear from senior management. I interned at one other company in my 4 years, and it just didn't feel like senior management didn't feel approachable at this other company that I worked at. So at Turner, I just remember being able to just speak to everybody. And like in this slide, this is Lisa. She's the Senior Vice President for Northern California. She oversees all of Northern California. And she was here just talking with the interns. There I am. There's Michael Bunn. He was a SJSU student graduated a year before me. So there's just a ton of people, ton of networking opportunities, and senior management especially is approachable, which I really appreciated, because it's nice to be able to just talk to anybody and not feel like you're not important enough to talk to them. And so these other pictures that I have here, what I really liked about Turner was that I was able to visit different projects, and this project right here on the right is a picture I took when I went to go visit the Transbay Center in downtown San Francisco before it was open. So I got to see it before it was open to the public. I got to go down to the basement, I guess you call it basement level. And this is just a neat picture I took that just shows the magnitude of the infrastructure there. This is a bolt, and it's probably twice the size of the hard hat, and it's just one single bolt. So it's like stuff like that. It just is super cool to see, especially seeing stuff that, if you're just the regular public, you'll never get to see this kind of stuff. And if it's interesting to you, obviously that's something really nice. So it was nice that Turner offered me that experience to go see the Transbay before it was open to the public, and I really appreciated that. And then some internship tips. My best advice for your internship is to just sit in on as many meetings as you can, because not only are you learning about the topics being discussed, but you're also putting your face and your name out there and to be remembered for the future. And like always, remember to ask questions. And I have a perfect example of that. On my first internship, I was walking on the site of the PG&E Livermore project, and I saw this gap all around. It goes farther in the concrete, but I was like, what is this gap? And I asked them questions. I figured out what it was. And now I know, for the future in construction, there's a lot of expansion joints, and these are just expansion joints. They fill them with some sort of filling. And just in case there's an earthquake, the concrete plates don't move or, don't fracture. They just move side to side. So this expansion joint just gives you that little bit of leeway right there. And that's something I never would have known. I never would have figured out if I just looked at it. But by asking around, asking people, I was able to learn about it. And now, I'll never forget, what component this is. And I've done that multiple times with multiple different things on projects. So it's just really important to ask questions. And then I'll obviously just converse with your teammates, with other interns, and with trade partners, because they know the work better than anybody else. So you can learn so much from just asking those people. So here's an example, something for the people that are thinking about doing internships. Here's an example of some work I did when I was an intern on the Livermore project. And the best part about this experience was just seeing work you had done now being implemented in real life. Obviously, this is a very small scale example compared to, project managers and VDC managers, but for someone just starting out, it's really neat to just, you're helping with something, because this is this is some backing that goes in on the wall, and it'll hold it. This one is a TV being put in place. This is a pantry being put in place. And it's stuff you never really think about if you're not thinking exactly about that part of the building. You're not going to think about, oh, there's stuff that needs to be attached to the framing so that I can put my TV up on the wall, because if you hang it to the drywall, it'll just fall over. So it's just stuff like that. And So this is something I did as an intern. I was able to go out in the field, measure, map where the backing should be. And this was all, I did this for multiple different areas. And this was all coordination so that I could send it to the framing contractor, framing trade partner, and he would put the work in place. He would put it, he would put the wall, the backing up exactly like that. And so it's really cool as an intern, you know, because you can't really help with huge parts of the project, but with stuff like this, it's important, and it's something that you can tangibly see be putting in place after you're doing some work on a computer. So I really liked that aspect of being able to get some assignments during my internship. So the full-time experience, I'm obviously just 2 months in. I just started, so this is brand new, but for the new hire onboarding, we have this thing called Back to Basics, which is a 9-month kind of program where once a month you meet with about 10 other new hires. So they're all new hires that got hired around the same time as you. And you're meeting to just discuss or learn about something. So like, for example, next week, I'll be going to a quality control Back to Basics. So we'll be having quality control managers speaking to us, talking about what it's like to be, what it's like to do quality control and how they track things and whatnot. So I think that's really cool that they have this program set up with other new hires so that you're also meeting other people, other new people, and getting that experience. We also have the new hired regional conference. I just did that. It was virtual this year, but it was all West Coast new hires. So people from Seattle, Denver, California, all on a conference, and we're all similar to the Back to Basics. You're just learning about the company, learning about the way Turner operates. And then like I'm hearing about other trainings that are going to be held in the future. I haven't like a lead training that Turner does. There's other trainings that they offer for employees where you can go other places. I heard there was one in Denver, there was one in New Jersey one year. So there's just stuff where you can go other places, have a little bit of fun, and also learn while learn about something new that you hadn't known. And then lastly, like I said, the approachable staff is always a great resource that Turner has, is that you could just ask anybody any question. They'll point you, if they don't know the answer, they'll point you to who knows the answer. But it's great to be able to just ask anybody for any resources or any help you need as a new hire. And then lastly, this rotation program, I put an asterisk next to it because it's brand new to, or coming back to Turner. I heard that it was a program in the past. I'm only the second person in recent years to go through this rotation program. So they're going to be getting my feedback, and hopefully it'll go on in the future. So if you do come on as a new hire in the future, you'll be having this, you could have a rotation program where you're able to see a holistic view of the company and network with so many different people. So this is a snapshot of what I've done for the past few weeks. I'm obviously right now I'm in VDC week, so I was actually with Matthew this past week. But just for the first week, I was with business development. So I was seeing how they chase projects. I was seeing procurement, how they get all the stuff ready for the project, estimating where they figure out costs of the project, material, what material is going to cost what. Cost is where they're looking at the budget, making sure the budget's always proper. The planning team, just scheduling with P6 and Lean, trying to make processes better. VDC, SPO. So there's SPO is self-performed. There's just so much different stuff that you go through in this rotation program. I'm super fortunate that I'm able to do this. And I just can't say enough good things about it, because it really is just an awesome opportunity to just see so many different aspects. Whereas if you just go onto one specific project, you might not see what the business development team does or the estimating team does until a year or two down in your career. So I really appreciated this rotation program, and it's an awesome part of the full-time experience.
So Miguel, we'll be relying on your feedback to see how we progress in the future.
Yeah, exactly. Yeah, so it's great. I'm excited for other people to try it, because you see so much in such a short amount of time. You don't get, you don't get details of everything, but you do get, you get to play around with stuff like this. This is what I just did last week with the VDC team. I had never used SketchUp before. but I used SketchUp for the first time, and I was actually able to 3D model my the PG&E Livermore project. So that was just really, really cool. I had never done 3D modeling before. I was able to practice. They gave me the time to practice. And then I was able to create this. And then we have some printers at the SAC office, Turner SAC office, and we just printed it. So it's really cool. They really care about their team members. It's very, you know, everybody at Turner is saying it, but it's true. They give you the tools, they allow you to learn, and you just ask questions, and you just become a sponge. So yeah, I really appreciate it. And that's pretty much it. Thank you very much. And I leave my LinkedIn and my email just in case any of you guys have questions or want to connect afterwards.
Hey, Miguel, there's a question from Tuan. He's interested to know, is there any other 3D modeling software Turner uses?
Yeah, well,
SketchUp?
the VDC team has Navisworks and Revit. So yeah, they have those different programs. I was just mainly using SketchUp because it's kind of a simpler one to learn and to kind of get your feet wet and learn first. But yeah, there's definitely other softwares, more complex softwares than SketchUp, like Navisworks and Revit. So yeah.
Yeah, Tuan, just to further that, you can use almost any 3D modeling software to make the model, and then you actually use the whatever 3D printer you have, you use the appropriate interface to print that model. So you can use any other